First of all, before my overview of our research tool, I'm now in Renmin University of China, and I really want to thanks for Professor Jia Feng and Han Tian Zhang, who is her graduate students here, their warm welcome and generous support at Renmin University of China. And because, yes, I'm here and I can use their eye tracker to give the demonstration today, and I can get access to their lab. So first, I want to talk about what is our purpose of implementing this Trados-2 Translog2 research tool. As Yuxiang last time showed about Translog2, this is what we did in the last decade since 2005 or 2006 with Translog2, that we collect translators data or participants data via Translog2. So for example, here is a professional translator. She is looking into the screen, and the infrared light is on, which is capturing her eyes and eye movement on the screen of Tobii Studio. Tobii eye tracker for this instance, and this collects eye tracking data, and also the keylogging data with that is our old data acquisition tool. And now we want to introduce Trados-2 Translog2 tool, because after so many studies we have done, we find that nowadays translators do a lot of post-editing work in their real life. So, but our Translog2 doesn't offer actually the professional editing possibilities. And also, as we can see from the last slide, the work environment is not as authentic as the real life translation environment for professional translators. That's why we want to use Trados as our new data acquisition tool, because according to our statistics in language industry, 80% of the professional translators are using CAD tools such as Trados. So this can simulate for our participants' real-world working conditions, and also increase the ecological validity of translation process research. And this is what we will show you later about Trados working environment when a real or professional translator is doing their translation work. And here on the left side is the source text, and on the left side is the target text window. And this is a very sophisticated interface for translation work. And they can even get access to translation memory upper here or term-based upper here. And for this Trados interface, they have Qualitivity plugin recently, and that can attract translators' keylogging data from Trados. And that way we can collect the keylogging data that happens in Trados when the professional translator is working on this interface or through this tool software. And here we have collect some data for testing. You can see a replay, which is a video we extracted or exported from Tobii software. And this, as we can see, this participant is working on the first segment of this session, and he's translating from English into Spanish. And at first he is typing very fluently, and then somehow he gets stuck here, and then he goes to the second segment, third segment, and even fourth segment to get some contextual information, and even further. And then he comes back to his target text and also goes to the source text a little bit. And I think at this moment, the red circles going everywhere around is what he gets from the contextual information. And as it is enough, he continues with his translation fluently. And this is what we call the translation process. We can look into this through either eye tracking data or keylogging data to see how they pause when they do translation, and how fluent their translation process is, or how disfluent their translation process is. I have to go to. And then for data collection, we need two streams of data. The first stream is what we call collectivity file that we showed from the one slide before. That is for key logging data, and this is in XML format. And this is one stream of data for key logging, and another streams of data is the eye tracking data, which is in TSV file. This is the output from an eye tracker. You can either use a Tobii or iLink to get this eye tracking data. And we need these two streams of data, which are two files, and we zip these two files together and upload to the TPR-DB management tool. And then these two streams of data can synchronize by timestamp, where the typing behavior and fixation behavior synchronize by at the same timestamps. And then we can coordinate the eye tracking data and key logging data. And for this procedures, we have basically 6 steps. The first step is we need to download and install Collectivity plugin. We suggest that you use the same version of Collectivity plugin as your Trados version. For this demonstration, we're using Collectivity 2019, which you can download from the RWS App Store. And the second step is we need to set up in Tobii Studio our experiment. For this experiment or demonstration we're showing later on, we are using Tobii 300X and the Tobii software called Tobii Studio 3.3.2. And the third step is you can conduct your experiment, either post-editing or translation from scratch in Trados, which we can collect the key logging data from Collectivity plugin. And for this demonstration, as I said, we are using Trados Studio 2019. And the fourth step is after the translator has done their translation session, we stop the Collectivity log, and then we export the Collectivity output. We should take the include keystroke data and export to XML format. These two things. We first have some concepts, and then afterwards I will show you how to do it in real experiment. And the fifth step is we need to export the eye tracker output. We need to export to TSV format. And we need to extract at least the following 12 columns. This I will show you and explain the features later when we are doing the experiment. And then the last step is we upload the eye tracking data and key logging data together in a zip file to TPR-DB management tool. And we need to choose the task name as Trados, and also we need to choose the other task name as -C, as we have mentioned recently a lot. And to wrap up, you need to conduct this kind of research using our Trados to Translate tool. It's suggested you have a TPR-DB account and the management tool. You have the access to the management tool, and this you can check via the CRITT website. And the second thing is you need to download the Trados Studio and the Collectivity with the same version. And this you can check via the Trados App Store. And the third thing I want to mention, in this demonstration, we're using Tobii Eye Tracker TX300 and Tobii Studio 3.3.2. But you can also do your experiment without an eye tracker and just using the keylogging data collected by Qualitivity plugin through Trados. It also works, and you can upload to our management tool as well. And I can show you later how we do it. So basically, we have 6 procedures to do this. And I will show you as a hands-on experiment from here in the Renmin lab. First, we need to click.
Okay, maybe we can ask. So Longhui will now give a demonstration of how that works. But are there some questions that anybody has and that they would like to ask?
Yes. Yeah, feel free to interrupt me anywhere when I'm demonstrating or when I'm doing the experiment, showing the experiment.
I do have a question.
Yes.
The Qualitivity plugin, this is a plugin
Yes.
for Trados or a plugin for a Translog?
It's a plugin for Trados, and it's free to download on
Okay.
Trados website, App Store. Yes.
Thank you.
If you have a Trados, then you can download from Trados App Store. Yes. And it will be on that interface when you're doing translation. Any other questions?
Then go ahead.
Okay. So we're demonstrating today that we use a Tobii Studio eye tracker, a Tobii TS300 eye tracker to do this experiment. So we first open the Tobii Studio and open the project. And we just click on start recording, and then we can calibrate the eye movement and fixations. As Yuxiang has shown last time, it's similar, but this is done on the Tobii Studio, like Tobii eye tracker software. So I will ask the helper, like a real participant, to show you. And I'm the experimenter now. Can you see my screen?
Yep.
Hello.
We can see very
Yes.
clearly.
Yes. So now we click on start recording. And now it's we call it P08, which is our participant now. And then it will pop up this calibration window. And then as we can see, now it's a very good distance between the participant and the Tobii screen. And the bar is red. And if he goes further, you can see that it cannot capture his eyes, and even the bars becomes red. So he should come back a little bit until it's approximately 60 centimeters or around 60 centimeters. That's a good position and distance. And also it's better we ask the participant to stay kind of still during the whole session, which is not that long. That can help us to get better quality of data. And now we start calibrating. And his eyes will follow the red circles very firmly. And this is like a 9 points calibration. and it will come back to this page, and it's fairly good. As we can see, it's only 1 point missing, but it's green, so it's fairly good. So we hit accept, and then we can hit start recording, and then it will go to Trados, and then we need to this one, right? And then we hit the project we have created in Trados, and for the participant to translate. Why? Don't click too much. Oh, okay. It takes a little bit time. And as we discussed before, the font is as big as enough. I mean, we set the font as 40 for this demonstration only, because usually the text is longer, and we don't want to scroll down a lot, so we cannot get this big font. So for this demonstration, we only have 2 sentences. We set the font very big for demonstration purpose, and then the participant can start typing and translation. We can see that he's doing, basically, we can call it the translation from scratch. And when he was copying from the source to target, he changed some words intentionally. And he may made some typos, and he can delete and insert. And he can also paraphrase some words. And then he needs to confirm the first segment. Yes, and then goes to the second segment. And for this one, you can see he's using a mouse to do copy and paste from source to target. And then try to change some words in the source text. And he's basically trying to check the target text, if it's okay.
Okay.
And then he confirms again. And then we need to save the translation by clicking this and hit yes. And make sure to hit OK here, then we can save the Qualitivity file. And then we go to this icon, which is the Qualitivity file. Is this one the time now? Yes. And then we can export the Qualitivity data by clicking Include Keystroke Data and clicking Export to XML format, and give it a path. We will save it here. I put it here as a folder A0523 CRITT demo. And then give it a file name as P08 T1. Yes, and save it. Yeah, this is already saved from this computer. And then the next step is we need to export the Tobii file. And now we can see the recording is finished. And then we can first try to replay what we did just now to see what happened. And then it will go for Tobii software. We can see that the red circles is his fixations. And it has some typing and going back and forth. And also the window switching from the source text to the target text when he's trying to copy the text from the source text to the target text. And this is what happens when he was translating from the first segment. And then we can see that in the second segment, what happens. Yes. And then now we see that the data is good and there's nothing missing. Then we try to do an area of interest, which we call AOI. We usually go until the participants go into the editor interface. Yes, we can go a little bit further from where he just started. Yes, and then we draw two AOIs because we want to see both the source text and the target text, what happens there.
Everybody knows what an AOI is?
Yes. And then we give the AOI names. The purple one, we give it the source
Okay,
text.
an AOI is an area of interest. And that means, so she has these two squares there on the window, right? In the Tobii software. And that means all the fixations that are produced inside, that are gathered inside this box will be captured and will be associated with this AOI, area of interest. And we will later, so the left side is the source text, the right side is the target text, and whatever gaze is on the left side will then be associated with the source text, and the gaze data on the right side will be associated with the target text. Okay, so because these windows don't move during the session, they can be defined once and then they stay throughout the sessions. And that's the idea of an AOI, area of interest. And you will see this later, how that is used. Okay.
Yes, yes. And let's see actually from here, as because we draw the AOI from the beginning of this session when this participant just go into this editor interface, and then we draw this dynamic AOI. So whatever it happens here, this two AOI doesn't change. And then we can see that all along these LIs are here. And even if you go out of this interface, it's still here, right? So we can follow everything happens there, theoretically, yes. And then after we drew this LI, we can do data export. We select the data set we just collect, which is, we take the P08, recording 04. That's the one we just collected. And then we need to extract the 12 columns I just told you, mentioned. And then we can actually save the columns we want to export every time. For example, here I just save it as Longhui. I just need this 12 columns. So every time I just load the settings of Longhui, then this is only this 12 columns I need. I don't get confused every time. And it's also saves some labor of ticking everything. So here we get one column from general data, which is called recording date. And then we can see that we also need the recording date is all. Oh, okay. Yes, now we're done with the experiment and continue with the data preparation. So we need to first get the recording date from general data, this column, which is the date when the recording was performed. Today is like May 23rd. And then the next one we need is the local timestamp, which is the computer time, I guess, from the timestamp data. And we click this one. And we also need key press event index and key press event, which is the keystrokes we collected through the eye tracker. And then we need 5 columns from gaze event data and AOI, which is fixation index, gaze event duration, fixation point X, which is the X and Y coordinates of the fixation point. And then the AOI, just now we get 2 AOI. One is ST and one is TT. So we get actually 2 columns from this one. So we get AOI ST hit and AOI TT hit. And then we get 2 more columns from eye tracking data, which are pupil left and pupil right. That's it. That's all we need for our data synchronization. And then after we choose all these columns we need, and then we export the data to our folder. Just now we get the Qualitivity file, desktop, and then this one. Yes. And before that, we need to change the file name as the same as the Qualitivity output, which is P08. And T1, because it's translation from scratch session.
So did everybody understand that there is 2 pieces of software running concurrently? Trados, that's where the keystrokes are recorded, and this Tobii software. And now she showed us how to extract the data from this Tobii software. And before she showed us how to extract the data from this Trados-Qualitivity file. So we have 2 files in that folder, right?
Yes, now we can see, we can go into this folder I created. We have 2 files from just now. One is the TSV file, which is the Tobii output, and one is XML file, which is from the Trados. And we can actually look into this data, what we collected just now. And this is the one we opened, just a Notepad++. And this has some drift, but we can see that we get the 12 columns I just mentioned, showing here from the Tobii software, which is recording date. Today is May 23rd, and local timestamp. We were doing this session at about 10:47 Beijing time. And then this is the seconds. It's 43 seconds. And then this is the millisecond, 8:04. This is the millisecond. And because this is Tobii 300X, so every 3 milliseconds it has a line. It has a row of data. So here we can see the first row is 8:04, and the next one is 3 milliseconds later, it's 8:07, and the next one is 8:10, right? So this is the local timestamp, and then the next column is key press event. It will be somewhere later because at first he didn't type. So we can see that here.
Maybe one can add these 3. So you can see every 3 milliseconds there's a gaze sample, and it's the sample where the left and the right eye are tracked. And you remember when Yusheng showed his experiment, we saw this with the red and green dots on the screen.
Mm.
So that's basically, and I guess the position of those dots is, so the last two columns, I think, is the pupil dilation, how the pupils are dilated, and the
Yes.
position of these X and Y positions are also somewhere encoded.
Yes.
So,
Yes. So if you have, I suggest that if you have a VS Code, you can open with VS Code, and then there is alignment, like they can just align each column in different colors. Then it's very easy to see the data for each column. Yes. And here we can see, just now I showed, like later when he types, we get some, yes, keystrokes. So this is the key event index, which means this is the sixth key he was typed, which is a E, right? And then what else we have? We have the fixation index. For example, here is the first fixation of him, and then it goes very far. It's until here is the first fixation, and then
so
the
I guess it means there's the first fixation has a duration of 493 milliseconds,
yes,
right? So means
yes,
every 493 milliseconds divided by 3 is like 130. No, how much? Well, how many is this? So all these gaze, so all these gaze samples are part of that same fixation. They are all clustered into one fixation. There was one question in the chat recently: how do we know what is a fixation? And that's of course a big question, and there are very many answers to it. And here we use a filter, fixation filter from Tobii, and there's very many ways how one can design those fixation settings. But anyway, here there's a certain setting, and this first fixation has 493 milliseconds with this huge number of gaze points.
yes.
Yeah.
And then this I need to explain because I see that we have this fixation point X and fixation point Y somewhere, maybe here. Yes. So this is the X coordinates and Y coordinates. I guess it's from here, the left corner down, right? For count
left
for
corner,
count. Yes. From here you count the X coordinate and the Y coordinates, and then you can from this X and Y coordinates you can know where this gaze point is on the screen. And then here this -1 and -1 means our AOI. If it's both -1, it means I didn't activate this AOI. As you see just now, I just activate when this participant goes into that editor interface. Before that, I didn't activate the AOI. So both columns are -1. But then later we can see after it goes into this interface, if he doesn't look either into the source text area or target text area, then it will be both 0. Means he's looking somewhere, but he's not looking into either source text or target text. And that will be both 0. And here, if we see that the first column is 1 and the second column is 0, means this participant is looking into the source text, because the first AOI is the source text. And if it's the other way around, if it's 0, 1, means this participant is looking into the target text. Because we only have 2 AOIs, so it's very straightforward. It can only be both -1 and then both 0 or 1 0 1 0 1, I think. And it's a very explanatory, straightforward explanation. Yes. And then after this, we get pupil left and pupil right. I think it's the pupil size, because some research talks about how the pupil size correlate with the cognitive effort, right? Or the translation difficulty. So we can also use this data from our columns we export from Tobii. And this is the Tobii export file. And then we can go into this one, the Trados output, to see what happens there and what this is like. So this is the collectivity output, as you can see here, because we only have 2 segments in our session just now. So we can see from the collectivity file, it's already segmented, the output. We can see here is the segment ID 1. So this is what happened when he was working on segment 1. And these were the keystrokes he was typed when he was in segment 1. And as if you can remember just now, he typed throughout the whole segment 1. So there are a lot of keystrokes here, as you can see on in the key columns here. He was basically copying, but by typing. And then we can see this is the segment 2. Yeah, there is also segment ID 2 that shows that this is what happens when he was working on segment 2. And here we can see that because he just did a mouse click and copy and paste from source text and target text, and he only changed one word here from suggest to propose, we can see from here. And this is, we can see both the Tobii output and the collectivity outputs are fairly good. And then after we check both files are good, we can zip the 2 files together. And then it becomes one file, one zip file, p08t1.zip. And then this is what we need when we try to upload to CRITT TPR-DB. We use Microsoft Edge today for demonstration. Yes, so we choose the file to upload, which is desktop, and then this one, which is the p08t1 zip file. And then we give it a study name. For example, here we give it maybe 0523 CRITT. And the collectivity file already suggests the source language and target language, so we don't need to choose it here. And we choose the task name as Trados. And for the tokenizer, we put -c in other task name, and we hit upload. And that we can see the first row of this interface is what we just upload to the TPR-DB. And we can go into it. After uploading, we can check what we get from TPR-DB. So these are the 2 segments we just work on. The left side is the source text and the right side is the target text. And this we can do either manual alignment. For example, we can click one by one and confirm one by one. This is one way to do this. And then another one, what we can do is we give it the same name with the same zip file. Just now we use 0523 CRITT, and we choose Trados, and we give it SI for automatic alignment, and hit upload, and wait for the automatic alignment. Because this session for demonstration, these are only 2 sentences, but when we are doing real experiment, there are a lot of sentences, and manual alignment will give you a headache. So if you can have automatic alignment, this will save you a lot of time. For example, we can check here. This is what we just did with the SI command. Then it already gives us a quite good alignment, because basically for this session we get a similar source text and target text, very similar ones. So we can see if it's gray when we are hitting the source text, and the target text is the source text is in purple and the target text is in red, and then they have a background of gray. This means it's already aligned, and we can check one by one. I think it's a fairly good alignment, and this we can see he just changed provides into serves, and all the others looks similar. Oh, and this one he changed places into conditions. He changed 2 words from the source text into the target text. And the second segment we can also check one by one, and he changed suggests into proposes. This we already saw in the Qualitivity output, and just by confirmation, and this automatic alignment is all good. And then we can just go back, and this is what we get on the CRITT TPR-DB. And what else we can do with this data is we can go to CRITT website, and from CRITT website there's a tab called CRITT TPR-DB, and the drop-down menu, the first one is Public Studies, and we go to Visualize Translation Progression Graphs. And here we get a shiny R interface that we can immediately get the visualization of our data. Just now we uploaded to TPR-DB. For this session, we use the user. It's a little bit slow.
Slowly.
Slowly.
Far
Okay.
away.
Okay. Yes. Yes, we can see that this user by default is TPR-DB, but for this session, we have uploaded to the account, which called Summer 2023. So we type Summer 2023 and hit Enter. Then this goes to the Summer 2023 account, and then we select the study we just collected, and this is the one 0523 CRITT _SI. That is, we already get the automatic alignment. And because there is only one session, we don't need to choose, and we can hit load selected session. And this we can see the immediate visualization of the fixations and the keystrokes we have just collected. And then because we have only 2 segments, we can see here there are about 30 words for the 2 segments. And this is the segment line. This is what happened in segment 1, and this is what happened in segment 2. And the blue circles is the fixations on the source text side, and the green dots is the fixations happened in the target text side, because as just now we mentioned, we choose 2 AOIs. So that can help. We see that what happens, which side, which window it was. And then what else we can do with this is we can zoom in to more details. For example, we can go into a certain time. For example, we see that the first keystroke is maybe around 45 milliseconds. Maybe we go there and see what happened by scoring right to 45,000 here. And then this is after his first keystrokes, what happens. We can see that he looks into some target set first and then source text, because the horizontal line is the timestamp. So it emerges with the time being. So the more right it is, it means like it's later happened. And the more left, this is prior, what is happened prior to this. And then we can also get into more details by zooming into more details. As we can see from here, he was typing speaking here, right? This is aligned to the first one, the first word. And then later is what? 2 languages. And I think for this vertical line, it's like by 2 words, every 2 words it shows. And the source text segment, we can go only for this first segment to see even more details. We can see here it's about 14 words for the first segment, so we go to 14. And then this is just what happens for the first segment, between 45 milliseconds to 56 milliseconds. And there's like a target text and source text fixations, and then target text, because he was basically typing. And then what else we can do? We can either then we can recover this for a little bit. And then we can get translation unit lines by ticking here, show or hide items. For here, we can click show TU lines, so that, and with an index here. So this means this is the first translation unit, and this is the second one, and so on. And for this is for translation unit lines. We can also go even more details, like production units. Here we can see this is where the typing happens. And then we can also add the AU lines down there. And this is even in more details, as you can see here with the index, with the AU type. And this different granularity of translation units can also be seen here by clicking show data tables. For example, here, if we click AU, then down there, it will show the AU tables. And this is directly related to what happens, what we see by the visualizations here. The data
excuse me, can you
yes.
please explain what does AU stand for?
So AU means activity units. For example, yes. Does that answer your question already?
Yes, it does.
Okay. Yes, so PU is production unit, AU is activity unit. So we can see the visualization from the progression graph upper there, or we can see what is the actual data related to this kind of visualization down here, which is the actual data we collected and generated by different features created by TPR-DB. And what else we can do with this is we can go back to the YAWAT tool.
Maybe you can go into a part of it and then explain a little bit so for instance, if you go again to that part between 45,000 to 55,000.
Okay, yes.
Because there you can see there's a couple of AUs, and there are 6 different types of AUs. Now, if you make this a little bit bigger there, yeah, so something like this. So they have different colors. And if you tick on what is it? TU lines, there should also be AU lines. Okay, there's only TU lines. Okay, in another thing, there's also, so this TU lines actually are a typing burst. So that's the gray box there, right? So that's coherent typing, and preceded by a pause that is longer, by typing pause that is more than 1 second. And that's, in this context, a definition of a translation unit. A translation unit would be some a typing pause followed by a coherent or by some typing events. And you see with these red lines that separate different translation units. And then the notion of activity units, there are 6 different ones. That is actually a finer grained fragmentation of a translation unit into smaller units, as you can see. And so we can have a concurrent reading and typing, which would be the yellow and the green, so there's also a number, no? So this activity units of type 6, they're the dark green ones. That is concurrent typing and target text reading. And then we have the blue one, for instance, is the type 1, that is source text reading. And then the yellow one is type 4, that is typing with no recorded gaze activity. So maybe the person was looking, was looking on the onto the keyboard. And the black one, the first activity unit, is just a pause. So we don't have gaze recordings and no keystroke. So we have 6 different kinds of activities, and this means either looking at the source text or looking at the target text, or concurrent activities means reading and typing, or no gaze data at all. Yes, and these are different kinds. All these kinds of different segmentation of the data is represented in different kinds of tables, as you can see here.
Yes.
Which we will start then. Which is then actually the interesting part, because we can then try to analyze the data based on the features in these tables. But that's what we will be talking about quite in detail in the next couple of days.
Yes, as you can see, I just clicked the ST table, and there are so many columns, which are the features we have. And if you want to know what is this features and what is it about, you can go to CRITT website. There are some here, like the drop-down menu here from the CRITT TPR-DB tablet. There's a features. If you have any doubts of what is this feature about, what is this column about, then you can go here. You just type the column you are not sure about. It doesn't show here. Maybe it takes some time. Yes, it's loading. And then you can just, yes, you can, for example, choose the table name. For example, I just want to look into the ST table. And then it will just give you the features in the ST table. And then it has some feature description that's very, very helpful. If you, of course, you cannot remember so many features, what are they all about, but you can always come to here to search and find explanation and go with it and play around with it, I think. Yes, And these are the Shiny R interface we are talking about. After you upload the data, you can immediately see the visualization. And also, Michael has talked about this yesterday, I guess, about the annotation. So we can also try to show how to do it as we open YAWAT after we upload the data, and we go into the data we just uploaded. For example, here we already did the.
Just let's ask whether there is more questions from anyone.
Okay.
There are some questions in the chat.
Oh, I didn't check. What is it? Is SI same as SA? So it's different types, but it's all from similar line. And we talked about this before. It's we tested the 3 similar line tools, and the SI is the best. That's why we usually choose SI, but you can use SA, or the other one is SM, I guess, right? So you can give this command SI, SA, or SM when you want to do automatic alignment. It's just according to our test result, SI is the best, has the best alignment quality. Yes, and another question is there a relationship between translation unit and activity unit? Yes. I think translation unit is bigger than activity unit. This is a very general answer. And also translation unit, we can see just now we showed. This is a translation unit. It can contain a lot of activity unit because a translation unit is what we have a coherent translation behavior, then we call it a translation unit, as Michael just explained. And activity unit is of more finer grained translation unit. It's smaller, and we have different types according to our research and results. Yes, and we have different definition of different kinds of activity unit. Yes. Are there other questions? No.
I do have a question, but
Yes.
this goes back to the recording in Tobii Studio.
Yes.
So I was wondering if the similar setup is possible with different CAD tools, like, for example, Phrase or MemoQ, or is this only possible with Trados?
Right now we are implementing with Trados because Trados has a very helpful plugin called Qualitivity that can track the keystrokes in Trados workbench. So for other CAD tools, maybe they have different plugin, then we need to test. Yes.
But in principle, it would be possible.
I
just need a plugin to get the keylogging data.
Yes.
Okay.
That's theoretically good.
Okay.
And oh yes, I forget to say that if you have no eye tracker, then you can just, for example, here, just now we get 2 files from our experiment. One is the Tobii output, and one is the Qualitivity output. If you don't have an eye tracker, you only have a Trados. Then you can use also the qualitivity to get the keystroke data, and also you just zip this qualitivity output, just one file, but still zip it. Zip. You can see here because just now I already zipped. So you can zip this one, just one file, the qualitivity output, and zip it, and the same uploading process as just now I did to the TPR-DB. Then it has only the keystroke, but you can also do analysis with only keystrokes data. And Devin Gilbert did his dissertation about this. He just used the qualitivity output, and he did his experiment with 30 or so participants, and he did some analysis. It's also good for research. If you don't have an eye tracker, you can still use Trados and collect the data, the keystroke data in Trados, and you can also upload and analyze your keystrokes data through our management tool. Yes. And what else? If you don't have any other questions, I can also show you if we can see, we just upload and did automatic alignment with SI, and then we can go into it again and see we can also do manual annotation. As Michael mentioned yesterday, we can click Open YAWAT, and then we can see we have, if we right click the mouse, we can see there this default translation errors. Here you can also customize it, and for here we have the default translation errors here. And then, for example, how can we manually annotate the translation product? For example, here we can see speaking to languages provides, and our participant paraphrase provides into serves. And we can say it's not good. So maybe we say it's a mistranslation critical error. We choose it by left click, and then we can.
Just Longhui, let me
Yes.
let me go and show how to change
Oh, okay. Yes.
the settings
Okay.
or the taxonomy.
Okay.
If you
So I stop sharing.
I'll just show how we can change the error taxonomy. So here it is. Here is the file called YAWAT Taxonomy. This one here, and it has here. Can everybody see this?
Yes.
And here it has these different kinds of labels. So the drop-down menu that Longhui just showed has this mistranslation, cohesion, and so on. And we could, for instance, if you were interested in metaphor translation or in annotating metaphors, you could just name this metaphor 1, whatever this is, okay? And if and this you could call it metaphor 2, whatever kind of way you have to classify your metaphors. Or 2, okay? So if I save this file here, then if you look back into
The last one.
okay, this one here. So I hope now if you look into this here, you can see that here it has now changed to metaphor 1 and metaphor 2, right? And you can basically yeah, so you can have your taxonomy here and you can replace these words here And if you have these mono annotations, you could have another kind of, what could that be, a mono label? It could be, well, it could also be in metaphor, no? Metaphor 3, oops. It could be metaphor 3, for instance. Three. Okay, so this would then appear on that mono side. So if you go back here and I undissolve this group, then we can go here and it has not, I guess I need to reload this. So it has metaphor 1 and metaphor 2 here. Dissolve this group, and then I can annotate this here with my label metaphor 3. Okay. So this kind of annotation here is now on that level. This file here, YAWAT text set, is on that level under the summer 2023 user. So this would mean that all sessions would have this taxonomy. We can also move this into one of the studies. For instance, move this YAWAT text, this annotation only into, what was the name of your session, 05 something? So why is it 0523, right? CRITT.
What's today's date?
The state?
Date. Today's date.
Okay. I see. Okay, so we can move this inside this folder. Okay, and then this would not be anymore on that level here, but would only apply to, so if we go back here, so I need to reload this, I guess. And if I reload this now, we are back. Oh, okay. So I'm here in this in the 0523, so that's still the same taxonomy. But if I go up into another session, then this should be the old taxonomy, right? So there are basically 3 levels where one can change this annotation schema, either on the level of a study. So all the sessions inside that study folder would have that particular taxonomy, or on the level of a user, means that all studies, so each of these folders is now a study, right? And they would all have the same taxonomy, or we take the default kind of taxonomy, which is on even for all the sessions. Okay, so that's how one can adjust the labels, the naming of these annotations, and then you can see that you can basically annotate whatever you are looking for. If it's metaphor or errors, or maybe difficulties or terms, or whatever your research question is. And then in a moment or in a couple of days, we will look these errors then will also be will be transferred to those tables, and you can then actually analyze this and count frequencies or relate this to behavioral data, how much time it takes to to produce a certain type of annotation, or how many revisions are there and whatever.
Just now, when you modify the error typology in the Jupyter, you modify the error typology on the right side. do we need to change the left side?
No, the left side, no, should not be changed because that is a label of a hash and that is used inside. So, okay, so I will go back. Where was it? Here. Okay, so if we look into now, where was it? 0, 5, 20. What is it?
3.
23.
Great.
CRITT SA. Okay, and then
Yes,
it was
SI.
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 Okay, and then okay. So if you look into this here, so this is the external label that appears on the screen, right? So in the browser, this is internal, and that should not be changed. Because then the program will just not work, the whole browser. And it means that, well, it was maybe when we conceived this at one point, it was perhaps not very wise to give them these meaningful labels. One should have just labeled them label 1 to label n, but now they have these labels, and these labels will then appear also in the tables. It's not this thing that will appear in the tables. It is these labels that will appear in the tables. So you would need to know what is, if you change this metaphor 2 here, then you associate this with this label here. Okay, and you would need to see in the tables it will be marked as cohes, but your meaning is here. Okay.
Yeah.
But I guess you just need a piece of paper, and once you work with this, I guess it's not so complicated.
Yeah. Another question is, can we add more, errors?
No, I mean that would also imply a modification of the code. I mean, in principle, everything is possible, but it would imply that you modify the server, the code on the server, which maybe takes a couple of hours work.
Okay.
For someone who knows. Yeah. Okay, so more questions? No?
I have
Otherwise,
a question about the translation progression graph. It seems that Longhui was able to do this on her computer, but I'm still not able to get that to work from the CRITT page. So I wonder if it's computer related or which browser we use. I have no idea.
no, well, it's actually related to HTTPS, and usually browsers. So this is an HTTP. It's not a secured website, and the browser by default always switches to HTTPS, but it
Yes.
doesn't tell us, and that doesn't work. So it must be an HTTP. So you can disable the browser to automatically use HTTPS. I also only know this since this morning. But in Edge, this Microsoft browser, they don't switch by default to HTTPS. So on Edge, it should work.
Got it. Thank you very much. That makes sense.
Okay. Otherwise, thanks a lot. And then we can stop recording. I hope I can.